Alright everybody, in today's video we are going to be looking at switches connected in parallel, which when they are, gives us the decision making logic of OR. In the last video we did switches in series which created AND logic, where S1 and S2 had to be closed to complete the circuit. In this scenario, you can have as many switches as you want in parallel, right? S1, S2, 3, 4, 5, 6, 7. As long as one of them, switch 1, switch 2, 3, 4, 5, 6, 7, 8, if any of them are closed, then current can flow and trigger the output. So switch 1 or switch 2 or switch 3 or switch 4, however much you want. So in this case, we have switch 1 and switch 2. When they are open, no current can flow through, right? So our output will be off. If switch 1 is open, but switch 2 is closed, current can flow and our output will be on. Okay, what if switch 1 is closed and switch 2 is open? Well, either or is closed, right? So our LED will be on. Okay, if S1 and S2 are both closed, guess what? Current can flow and turn on the output, right? So when in parallel, the only time the output is not on is if all are open. The circuit will be incomplete. Alright, next we'll move on to the simulation portion, and then we'll get on to the hardware build. Alright everybody, here we are at the simulation portion of two switches in parallel. Here's our schematic for it. Just very simple. We got our two switches, our current limiting resistor, and our LED. In this case it will be green. Yeah, not much to it. I'm going to now just go ahead and ground our cathode side of our LED, and then hook up to 3 volts. Okay, so let's go ahead and run our circuit. Okay, so as you can see, both switches are closed right now, so our output is on. And remember, in parallel, it's either or closed, right? We should expect an output to be on. So if I were to open either one of these, the output should remain on. There we go. It's or. But when they're both open, nothing. But as long as one of them are closed, making a connection, the circuit is complete. So there we go. Let's go ahead and move on to our hardware build and get some hands-on with this two switches in parallel. Alright, let's get started here. So I already have my buttons installed, units unplugged and powered off. Okay. So there's several ways that you can do this, like always. But I'm just going to bring in my 3 volts to a common node. I'm just going to follow the circuit diagram. Okay. So we have our power coming in. And then off of that, we're going to go into an input on the switch. So let's just say let's go to the top of our switch. Okay. Then the output of our switches will go to a common node. Let's see, can I get it closer? Okay. Then after that, we have our current limiting resistor going into the anode and then out the cathode to ground. So we got our 1.5k ohm resistor here. Okay. To our anode. And then we will ground, of course, the cathode. Okay, just double check real quick. Okay, looks good to me. Let's go ahead and plug it in. Power it on. So right now no switches are on, and as we would expect, no output. Our LED is off. So now let me go ahead and close switch 1. Okay, output on. Let's close switch 2. Output on. And remember, if we close both, our output will also go on. So switch 1 or switch 2. This is what it looks like with switches in parallel. Cool. Hope you learned something, and I will see you in the next one.